We'll be solving LeetCode number 1306, Jump Game 3. It is a medium problem on LeetCode and it is also the daily problem for today. Now, Jump Game itself, it has 1 and it has 2. I would say that at least for 1 it's different. I haven't done 2 yet, but for 1 it required a basic traversal of the array. I've covered that on the channel already, but I would say that doing 1 and 2 is not a prerequisite to doing 3, so I would definitely attempt 3. It touches on a different topic. Now, what is Jump Game? For the people that don't know Jump Game 1 was you start at the starting index, so you start at 0 and you're supposed to reach the very end of the array, so len array -1, that particular index. You reach this index by taking jumps that are at their corresponding index, so we would say 0 plus x, and then we would do this multiple times. Let's say y plus 1 as well, something like that, and you reach your index, and if you do end up hitting the very end index, you return true. Now that was Jump Game 1, right? And the premise of this question is also pretty similar. You're given the array of elements 4, 2, 3, 0, 3, 1, 2. I've taken this example from LeetCode itself. We can label this 0, 1, 2, 3, 4, 5, and 6. At every index, right, we have 2 options in this scenario. So when we are starting at index 0, we are also given a start index, by the way, in this question. But yes, the first thing we are okay, so let's consider 0, right? There are 2 things that we can do. 2, right? We can do 0 plus 1. This gives us 4, right? That corresponds to the index number 4. That means the value 3 in this case. And we can also go negative, right? 0 minus 4, right? We will get -4, and this corresponds to nothing in the array because we can't go less than 0. So we skip these values. We skip values that are greater than or equal to the length of the array, sorry, and they fall out of bounds essentially. So we would skip this. We would not consider this. Okay, no considering. Now, in this question, we are given a starting index, right? So the first one we're given 5. So what I'll do now is I will run through the by hand approach of how do we solve this. So we start at 5, right? And okay, let's consider index 5. We see, let's write out the index over here, then let's write out the element at that index, +1, -1. We see 6 and we see 4. Now at 6 we have 2, at 4 we have 3, and also our goal is supposed to be any element. Essentially we are supposed to find 0 in the array. We are supposed to find 0 given this start value. Can we get to a array index such that it is equal to 0? That's all we have to do. So 5 plus 1, 6, and 5 minus 1, 4, right? Those 2 corresponds to 2 and 3. So let's consider 2 first. Let's explore all of 2's paths, let's say. Or we'll consider both of them. Let's consider both of them. We'll do 2 and 3. Let's do 3 first. So 3. We check at, we see that 3 itself, right? 3 already in array 3. We already get 0. So the thing is, we will return true immediately as soon as we see it. But for the purposes of this question, I'll go with 2 instead now. Just to explain what's actually going on, we will do 2 now. 2 plus 3 and 2 minus 3. This will go out of bounds. -1, sorry. And we will do 5 back here, right? So we see that 2 doesn't lead us anywhere, but 3 actually did, right? But what was the approach I took? So in this one, what I did was I calculated the two options, right? And then we explored both of the options to see whether it was going to give a 0 or not. If not, we would have proceeded with it. We would have gone with the 5 again, and 5 would have brought this back to us, right? So we would have essentially, all we've done is we've considered our options, and we are now exploring our options. And this is very much like a BFS or DFS type of question, right? A BFS or a DFS type question, because what you're doing is exploring paths. If you studied graphs, then this is like exploring paths. I would heavily suggest studying graphs before approaching this question, but yes, this is like exploring paths. That's all there is to it. You could run it as a DFS or you could run it as a BFS. I used BFS personally, and the way we set up a BFS approach for graphs is we would have a visited set. And this question was actually a very good example. 5 over here, right? 5 over here. If we check 5, we know that we already visited 5, right? We've already done 5. And we would go back to 2 again in some scenarios. So how do we keep track of what we visited? Well, we have this visited set. And with this set, we made it a set because of the lookup. We want to have a fast lookup. But yes, this set essentially just helps us keep track of all the indices that we have seen so far. And right from the get-go, we will say that we have checked our start, because that's what we will be doing. And in BFS, we use a queue. So I will start off with the starting index, and we will make that a queue, right? Now, while queue, that means we still have paths to process. Our index that comes out is queue.pop left, right? And I'll call this front, I'll call this back. Essentially all that it is IDX, like the index that we were at, plus the element at that index. And there were two options, right? One with the plus, one with the minus, so we just consider both of them. Now I will have two flags. Consider F. I'll set these to true initially, and this is essentially just for the bounds checking, because like I said, we can't go outside of the bounds. So now we will do if consider F, if front is greater than or equal to len nums, that means it's falling out of bounds, right? We don't consider F essentially. And we do the same for back. Back can't be less than 0, right? So consider back would be false, right? Now we've written out the queue, we've written out the front and back, we've seen if we should consider them. Now if we do consider them, consider the front element, right? So the value at that next index, value at the next index we have, that will just be array of front, right? And the way this is very helpful for catching the 0 early. So if value at target is equals to 0, then we can immediately return true. This helps us catch it early instead of having like another check in somewhere else. But if it is not, then we will only explore this if it's not in visited. So we will have another explicit check. If front not in visited, then we would add it to our visited first of all, and we will also add it to the queue, so it would become like an index to pop off later. And it's the same exact thing for back, so I'll just copy that over so that's easier for me to show it to you guys. So if we just have this, then now we can just do the other check. If consider B, array back, if value target return true, if back not in visited, then we will add back, we will append back, right? And if we run out of all paths to process, then that means that we never actually found the zero, so we would simply return false at the end. And that's pretty much it for this question. A bit lengthy in terms of code, but the approach itself is very simple. It's just a regular BFS. Do graphs if you haven't, and then you should definitely approach this question. It is a very good question.